Now, before we jump right into using Cramer's rule and actually solving the systems, let's just practice writing this. So if we weren't trying to solve the system at all, and we were just trying to represent the systems of equations, using a matrix equations, it would look something like this. So we'll have three separate matrices. One representing the coefficients, one representing the variables, and one representing what your equation is equal to, or your systems are equal to. So for number 5, if we rewrote this, our coefficient matrix, coefficients, remember, being the numbers that are attached to your variables, would be -2, -4, 1 in front of your x that you can't see, and 5. If we then multiply that by our variables, the only variables in this case being x and y, it is going to equal 10 and 2. And remember, the way we multiply matrices, we would multiply that first row, which is -2 and -4, times the column in our second matrix, which is x and y. So -2 times x plus -4 times y becomes -2x minus 4y, and that's going to equal your first spot in that last matrix, which is 10. So we're pulling what we have in our systems, putting it in matrix form. So if we look at number 6, same thing again. Coefficients 5, -3, 7, and -1 will be your coefficients matrix, times your only two variables that you have, x and y, equals 1 and 3. So we're not solving here, we're just rewriting, but that's what it would look like in matrix form. So let's go ahead down below here and actually use Cramer's rule, and we're going to use that determinant that we've just practiced finding to now solve for systems of equations. So when you guys have a system of two equations, two variables, x and y, you guys know how to solve this. We've learned how to solve it graphically, using elimination, substitution. You've done it in Algebra 2, in Unit 0, you've done it in Algebra 1, you probably covered it in geometry. So this is just another tool for you guys and another way to be able to solve for systems of equations that have multiple variables. Finding the solution for x and y, that intersection point. So if we have two equations, like it shows here, x plus by equals e, cx plus dy equals f. Both have x and y in them, two equations, a system. As long as your determinant of your left side of your equation does not equal 0, then the system has exactly one solution. That's what we are trying to find. So what happens is you find the determinant of that left side of your equation, that's your A. So once you find that determinant, you're going to use that to find x and y. So the first thing we do is find x. And when we're solving for x, we replace, we're not using the coefficients that x are attached to because we're trying to solve for x. So if we're solving for x, we're going to replace a and c with what's left over there on the right hand side. That sounded confusing. We replace a and c. We replace the coefficients attached to your x variables with what the equation equals. And we leave b and d because they're attached to y. So vice versa, when you're solving for y, you keep the x coefficients and you replace the coefficients attached to y with e and f. So you need to find the determinant of your matrix A, which is that left side of your equation, and then you need to solve for x and solve for y using that determinant. So the first thing, probably easiest thing to do first, is find the determinant of A. So that's going to be this left side here. And we'll just call it A for now so you guys know where I'm pulling these numbers from. So the determinant of A is going to equal, let's see, 3, 1, -2, and 4. So 3 times 4 is 12 minus 1 times -2, which is -2. So the determinant is 14. So that is going to be that value that you're dividing by. So let's solve for x first. So we don't use the coefficients in front of x. We replace those with what our equation is equal to. So in this case, x is going to equal the determinant of 22, -2, and then our coefficients attached to our y, over that determinant that we found to be 14. So this will equal 22 times 4 is 88. Minus -2 times -2, which is 4. And we divide it by 14, which we already found. So 88 minus 4 is 84. And 84 divided by 14 gives us 6. So x is going to be 6. So we've now found x. We need to find y. So y is going to equal the determinant of 3, 1, 22, and -2. Again, we keep the coefficients with the x, replace the coefficients with the y with what our equation equals, over the determinant, which still is 14. So this becomes 3 times -2, which is -6, minus 22 over 14. So -6 minus 22 is -28. Divided by 14 gives us -2, not +2. So the ordered pair, or the solution for this systems of equations, will be 6, -2. 6 being x, -2 being y. So, steps: find the determinant of that left side of your equation, where your x and y are. That's what you divide both equations for when you're solving x and when you're solving for y. So let's just try another one. Let's do number 9. So again, just two equations. 3x minus 2y equals 8. And 4x minus 3y equals 10. So let's find the determinant of the side with our variables on it. So 3x minus 2y and 4x minus 3y. So the determinant of that is going to be 3 times -3, which is -9, minus 4 times -2, which is -8, is going to be -9 minus negative becomes plus. So -9 plus 8 is -1. So that is our determinant. So now we need to find x and y. So for finding x, remember we're not including the coefficients with x. We replace those with 8 and 10. Use the coefficients for our y. Divided by the determinant, which we found to be negative 1. So that's going to equal 8 times negative 3, which is negative 24, minus 10 times negative 2, which is negative 20, over our determinant of the left, which we found to be negative 1. So 24 minus negative 20 gives us negative 4 over negative 1, which gives us 4. So that's okay. Now we need to find our y. So y equals, keep the x coefficients, replace the y coefficients with 8 and 10. Over our determinant, which we found to be negative 1. So this will be 3 times 10, which is 30, minus 8 times 4, which is 32, over our determinant of that left side that we found to be negative 1. So y will equal negative 2 over negative 1, which will give us 2. So our solution for this system of equations will be 4, 2. And you guys can always check it, remember, by graphing. That's the quickest way to do it if you're able to. You can also always plug it back in and just check. So maybe that would probably be the easiest way. But you can always check to make sure that you did it correctly. Alright, I'll do that last one on the page with you guys as well. So let's go to do number 8. Okay, keep on moving along here. Two systems again. 3x plus 4y equals 2. 2x plus y equals 3. So let's find the determinant of that left side there where our variables are. So 3, 4, 2, 1. The determinant will be 3 times 1, which is 3, minus 2 times 4, which is 8. So our determinant is negative 5. Okay, good, wonderful. Now that we have our determinant with our variables, we can actually solve for our variables. So let's solve for x first. So x is going to equal, replace 3 and 2. Don't keep those coefficients with the x's. We replace them with what it's equal to. So 2 and 3. Keep the coefficients with your y's. Over the determinant of the left side, which we found to be negative 5. So x will equal 2 times 1, which is 2, minus 3 times 4, which is 12, over negative 5. So that gives us negative 10 over negative 5, which gives us positive 2 for x. Let's go find y. Y will equal coefficients with your x's, so 3 and 2. Replace the coefficients with your y with what your equation is equal to, so 2 and 3. Over that determinant of the left-hand side of your equation, which we found to be negative 5. So y will equal 3 times 3, which is 9, minus 2 times 2, which is 4, over negative 5. So 5 over negative 5 is negative 1. So y is negative 1. So your ordered pair or your solution for this equation will be 2, negative 1. So, hopefully not too bad. Just, again, another way matrix or matrices are useful, and one more way you guys can solve a system of equations. In the future, or down the line here, we will look at using this to be able to solve a system with 3 variables. That's where it really comes in handy, because we haven't done that yet. But stick with this for now, and let me know if you guys need help.